Hey there guys, and welcome to the LabWorks YouTube channel. Just like to go through with you how to create a Lego part, but the special thing about this Lego part is that it generates the shapes and features based on your parameters that you provide, so it generates it dynamically. So let's go through. I'll show you some different ways that we can manipulate this example, and then we'll get into creating our own. I can enter some values here, so I'm going to enter studs long and wide, and whether there's studs on top. So let's go 12 studs long, 2 studs wide, and we'll pop the studs on top. And I'll just go through another one here. Let's have a look at another example. Let's say 4 long, 2 wide, units high, and we'll say no studs on top, so we get a nice smooth piece there. Let's just do one more. Enter. Let's do, for example, so you can see here down here on a Lego block that's 2 studs wide, or any studs wide more than 1. It's got these patterns here. But if we were to change that, let's change that to 6 long, but 1 wide. Studs on top, yes. So now we've got those solid studs in the bottom as well, just like the Lego specifications. For example 2, let's just do one more. We'll do a 1 by 1. So 1 by 1, studs on top, and then we've got that. So it creates this nice little block that's based on the Lego standards. So what do we need to do to achieve this? Let's have a look. So again, I'm Anthony Musgrove, Senior Engineer with LabWorks Australia. Let's go through why Lego. Why did I choose Lego for the demonstration or the tutorial? I think that Lego's a pretty universal sort of thing around the world. The standards are universal, the sizes are universal, dimensions, etc. Everyone's heard of Lego, so it's something that we probably all either have or have had in our hands at one stage of our lives. Might even have some in the house, so I figure it might be a little bit easier to use a common object. Before I start getting into the content though, I'd like to give a massive shout out to Dave Martin. Dave Martin is an awesome, amazing YouTube tutorial guy on computer-aided design and a bunch of different things. He's given me the inspiration to get this recording done and hopefully continue recording. And Dave, if you're listening, mate, you've got an amazing voice. As I said before in those comments, you've given me the inspiration to get out there and start creating some content of my own and see how I go with things. So thank you very much, Dave. So check him out on YouTube, CAD PLM guy. What you'll learn today is basically what I showed you in the demonstration. We don't need to go through that. I'll give you a copy of these slides so you can go through it if you need to. Just a quick slide on the dimensions, which we'll come back to and refer to. Variables and parameters, which we'll get into as well in the program, but we'll go through that shortly. Relations and the conundrum of, so basically the idea is we build one CAD file that can create different Lego blocks based on your user parameters or the user's user parameters. For example, if it's a 1 by 1 block, it doesn't have a stud underneath. If it's a 1 by something, it's going to have solid studs underneath. And if it's a 2 by or whatever by whatever bigger than a 1 by something, it's going to have those hollow studs on the bottom. And there's some conditions and logic that we're going to use. They're just if statements. We'll go through all that though. And the Pro program, which is a Pro program, is the the back end basically of how CREO Parametric puts together a part once you've modelled it, or as you're modelling it. It's basically the text-based programming language behind creating the parts. So we can go through all that as well. Alright, so on to the first step. What we'll need to do for our first step is we'll need to create a new part. What I might do though is close this one, and we're going to create a new folder, Lego block tutorial. Okay, so we're going to work in metric because that's what all our dimensions are in. We're just going to create a new part, and we're just going to call it a Lego block. Look, can't do that. Lego block tutorial, and I'm using the millimeters, kilograms, seconds, absolute template. Okay, so once we're in here, all we need to do really to start is we need to do an extrude off the top plane, and we're going to chuck in some center lines. I'm going to create a rectangle, and we'll make sure it snaps symmetrical on each side here. Doesn't matter about the dimensions, we can leave them as they are. Click OK, and we've got that there. I'm just going to do symmetrical so it's nice and centered in the in our plane on our datums, and I'm going to click OK. So there's our first bit. So save that out. So that's our first task. Second task is going to be creating some parameters. Now parameters are variables that we're going to use to create our geometry. So if we go back into our references here, we've got some parameters and variables here. So we're going to pop these in here. Let's create our variables here. We're just going to add variable, and we're going to add a single unit height. It's going to be a real number because it's got a decimal point. If it was just a full number, no decimal points, no fractions, it's an integer. We've got different other values here too, strings and booleans. Yes, no. We're going to use a real number. I'm going to put in our 3.2. And we'll plug in the rest of our variables. Stud diameter. Our stud diameter on top. Now, as I've got here, all the references point to 4.8 millimeters for the stud on top. I've measured them with calipers, and they are a little bit bigger. But because I do this for 3D printing, I found that 4.9 millimeters gives it a little bit more ability to stick to the other parts properly. So I'm going to use 4.8 here because that's what the standard states, but you can change it to 4.9, and if you're going to 3D print it, you may need to play around with these values anyway. It's all based on your printer's abilities and tolerances, etc. So the next one is our stud height. And again, the standard says 1.8 or 1.7. I've seen 1.7 and I've seen 1.8 on here. Let's have a look here. So here we've got 1.8, but other examples I've seen 1.7, 1.8. I've measured them again with the calipers, and I've gotten closer to 2. But we'll just leave it as what the standard says, 1.8, and you can play around with them values however you wish. So then we've got some parameters here. Now we'll put these parameters in here as well so we can manipulate them. So studs long, it's going to be how long or how many studs long the part is, obviously. And that's going to be a real, that's going to be an integer because we can't have half studs. So at the moment I'm just going to do 4. But we'll be able to change that later, obviously. Okay, studs wide, and we'll make that an integer as well. And we'll make that 2. So that's our standard 4x2 Lego part, which is this part, this tile here. Studs wide, units high, so we'll go units high. Now, just an explanation on the units and how I've done it here. Single unit high is 3.2, and that is the thickness of one of these flat parts, Lego parts. So it's the kind of the smallest, the thinnest part. So because it's the thinnest part, I've called it a single unit. And you'll see on the next slide as well that the part, the full part, or sorry, the standard part is 3 units high, which is like this, and that there is 3 units high as well. So you've got 1, 2, 3 units, but we're going to use units high. And we're going to use it as an integer because this is going to be an integer value. We're going to go 3. So we're going to create this standard part here first. Excuse me. And studs on top. So studs on top, and that's going to be a boolean or yes, no. Whoops, yes, no. And we're going to say yes for the standard one, so we can create something with the studs on top. So if you wanted to create a smooth part, you just turn that off, and that's what it would come up with. So we'll just click OK on the parameters part at the moment. Nothing's going to change here just now. And here we have our relations. So we're going to need to create these relations here. Now I'm going to create the relations in here as well. So relations is just accessed by clicking over here on the model intent ribbon, the model intent overflow, and down here to relations. And this here is where we type in all our relationships for our parameters to create our geometry. So if we have a look here, we're going to basically put each of these relations or each of these formulas into here. Distance between studs, so that's going to be calculating the distances between the studs on the part, on the top of the part. So we can put a comment in as well. Comments is just a slash and a star, and we're going to say distance between studs. And I like using variables that actually explain exactly what we're doing. It's just part of my background to make it a bit easier to understand large projects and large code, because a lot of the code that we work on is it's rather large and complex, so we like to keep things simple as we can. So distance between studs is 2.5 times, and the single unit height here, remember we put this in to our parameters before, so we can actually go through here, click on this little drop down here, local parameters, and we can go down and we can find our parameter that we've put in. So we're looking for single unit height, and there it is there, single unit height. We can right click on that and we can go insert into relations. You can also manually type it, but I like to use that functionality there, so I know that I'm not getting typos. But by all means, if you want to type it in manually, go for it. So block height, and again I'm only putting the comments in there just to show you how the commenting works. You don't need to put comments in if you don't want to, but it's probably best to just to keep it nice and tidy. We can a bit more explained. So block height equals single unit height. So again, we can insert it from our relations, from our parameters list. Single unit height times units high, and units high is down here. That's another one of our parameters that we've put in, so we can just right click and go insert into relations. So that's basically saying a block height is a single unit height, which is 3.2 times however many units high the user wants to create that block. So that's going to be defined, well, it's defined here, but it's also going to be requested when the part gets regenerated. So again, we'll just keep going with these. We've got part length equals studs long. So how many studs long the part's going to be, times distance between studs. So this here is a variable that we've created up here. It's not actually in our parameters yet. So we can just copy this variable here and paste it in to here. So studs long times distance between studs minus 0.2. Now these are just variable. These are just formulas that I've actually got from, and I'll show you where they're from. They are from this one here. So these are our formulas that that I've gone off here. So as you can see here, we've got this height here is 3.2, and that's a single unit height. And our distance between studs is P, and if we have a look, P is generated by well, we can calculate P out, which I've already created the formula for. So we've got this here again, 4.8 millimeters diameter, 4.8 millimeter diameter of the stud, 1.7 millimeters high, and then we've got this part height here of 3 times h, which is 3 times 3.2, which gives us our standard block size, or our standard block thickness. So that's where the formulas have come from. Yeah, I'll pop this in the documentation as well. So we'll keep going on with our parameters. So the next one is part width. Our part width equals our studs wide. So again, we can right click down here and get insert, times, and again, distance between studs, which we can copy over here and paste down here, minus 0.2. So we pop them in there. So now what we can do is we can click on here, the validate, and validation will let us know if there's any errors in our relations that we've typed in, if there's any, not so much typos, but if there's an invalid function or invalid statement or invalid variable, it'll let us know. So we're all happy there, and we can click OK. So now again, nothing's going to happen yet, so we can regenerate the part. Nothing's going to happen right now. But what we wanted to do here now is we can start linking our relations, our parameters, to the geometry of this part. So I can just rename this to block. You don't need to. So what we'll do now is we'll link our values from our relations. So if we go down here and have a look now, now that we've validated, what we can see is we'll get some new parameters. These parameters here, or these values here, will also be calculated down here. So now if you have a look here, our calculations have produced these variables, or these values. So distance between studs is 8, and that's based on those calculations, and this is all based on our studs long being 4 and our studs wide being 2. So if we have a look at our example back here, we can see that we've got 15.8 wide, 31.8 long, that's millimeters, and we've got 8 millimeters gap between each stud. So if we have a look here at our parameters, we've got 8 millimeters between studs. Our block height is 9.6, which is okay, we can confirm that later. But if we have a look here, we've got our part length 31.8, which reflects the same here, 31.8, and our part width 15.8, which reflects the exact same thing here, and again 9.6 is just there. So everything checks out for this block so far, and we haven't had to manually model that, which is perfect because we're calculating it based on what the user needs to create. So to link these relations now that we've got these here, we're going to click on our block, and we can see that it gives us our dimension value, or dimension codes here, or designators. So we've got D0, which is our part height, D2, which is our part long, and our D1, which is our parts wide. So what we do to link these, we just click in here, and then I'm just going to put a comment here, linking dimensions to part designators. So if I click on D1, D1 is going to be, it'll come up here, and D1 is our part wide, or part width. So again, we can right click on it now because it's been created down here, and we can go insert, and we've got our D2, oops, sorry, got to click in over here. D2 is going to be our part long, or part length. So we're going to go here and insert part length, and D0 is our part height. So we need to find our part height, which is block height, 9.6. So we just need to insert the relations here. Now if we validate that, it says that it's successfully validated, which is great. And we click OK. Now if we regenerate, now we can regenerate by clicking regenerate up here, or we can press Ctrl G. I use Ctrl G, but let's hit regenerate, and you can see now the part has now reflects the size that we need for that one block. So we can confirm that by clicking on it here, and then our quick menu here, just hit the dimensions, and you can see that now it reflects 31.8 wide, long, 15.8 wide, and 9.6 high. Okay, so now that we have our Lego block reflecting the stud, the size of the block for the studs on top, and what we'd expect the size of the part to be, we need to start adding the studs. Now, before we add the studs, I just want to refer back to this slide here. We can see that from the outer edge of the block to the center of the stud, the outside, so that's the padding on the outside, is 3.9 millimeters, and it's also the same in this direction as well. So we're going to remember those values. We'll add them values in as parameters, just in case down the track you'd like to change it and create your own different stud configurations or different ideas. So we're just going to call it stud padding long or length, and we're going to say 3.9, and it's going to be a real number because it's a decimal number. And we're going to get stud padding width, and it's also going to be 3.9, and also a real number. So we'll click OK on that, and that way then we can, if we need to change it one day to do something different to a part, or even create your own version of Lego, etc., because we all like to be unique and make things, we can modify it there. So the next step is we're going to create a stud, and I'm going to start from up the top left. So we'll just click on our top surface where we're going to do our stud extrusion, and we'll just hit extrude. I'm going to switch to my sketch view. Now because we know our dimensions from the edges here, we're going to add them as our reference points for this sketch. because we're going to be coming down 3.9 and across 3.9. So what we need to do here now is put in our circle. It doesn't matter where we put it, how big it is at this point in time, as long as we have all these dimensions here that we can modify in our relations, link to our relations. That's all we need to do is click OK, and we'll just click OK on that one as well. And there's our little stud, and as you can see, it doesn't look like a stud, doesn't even look close to the right size at the moment. But that's okay, because we're about to link it to our relations. So we'll click on our model intent, and we're going to click on relations, and underneath everything here we're going to go stud relations. Again, you can use comments, you don't have to. What I might do first though is I'll just click OK on that. I'm just going to rename this to stud, just to make it a little bit easier for me to refer back to it. So we're going to go back to our relations, stud relations, and here now we can see we've got all the dimensions here that we know the dimensions. We've got them all here ready to go. We just need to plug them in and link them. There's one. Just copy that there too, so we can see that that's what it is. So what we need to do now is link them together. So I'm going to do, the first one I'm going to do is this one here, D10, which is the stud diameter. So D10 equals, and we'll find our stud diameter and right click down here and insert to relations. And the next dimension that I want to do is D9. So D9 is our stud height. So we'll just select that one. D9 equals our stud height. So again, we right click and insert into relations. So we've got our stud diameter, we've got our stud height. Now we've got our D12, which is our padding, or our stud spacing width-wise. So we're just going to go stud padding width, and we'll insert that one into our relations. And we're going to do the same with our D11. But that is going to be our stud padding length, which we'll insert. Now again, we can hit our verify to make sure that everything's correct. Everything's correct there, and now all we need to do is regenerate. And again, you can either regenerate by clicking the regenerate tool up here on the toolbox, or we can press Ctrl G. And there is our first. Okay, great. So now that we've got our first stud created, we need to create a pattern to duplicate this stud for the amount of studs we want to go along and wide on our part. So to do this, we need to click on the stud. We'll choose the stud over here in the property tree, in the feature tree, and we can either choose pattern from our little dashboard box here, or we can use pattern up here. And we're going to do a pattern. We're going to go direction. So our first direction is going to be towards this surface here, because we want it to go along the part, the length of the part. So our direction, or our pattern, is going to go to the direction of the surface that we select. So we're going to click on this surface here, and we can see that it's now got, it's creating a second stud, and it's going to be spaced 6.6 millimeters apart, which is fine. We can just leave that for default. So I'm just going to change that to 3 so we can see 3 studs. And then we've got our second direction, and we want that one to go this way, and we want we'll just leave that as 2 and leave that as 6.6 spacing. It doesn't really matter at this point. We'll just click OK on that, and we can see we've got our 6 studs, and as you can see, they're not really in the right spots. And if we were to try and create that and connect it to conventional Lego, the conventional Lego is going to go nope. That's okay. What we need to do is we need to link our patterns, or our pattern here, to our model's intent, or to our relations. So we're just going to click on the model intent overflow, and we're going to go to relations, And then down the bottom underneath everything, what we need to do here is we need to select our pattern. Now you can see here, it looks a bit complex, but that's okay. We just need to make sure we choose the right values or the right dimensions. And we're going to do that nice and carefully. So we're just going to see. So what we're going to do here is we're going to go to Stud Patterns. Stud Patterns Dimensions. Now this is where, so we've got all our values here that we need for this to link to here. But what we need to do is make sure we link the right values, or the right values to the right dimensions, or the right variables to the right dimensions. So this D18 here, as you can see, is the stud spacing between studs. And so same with D19. So we can get those two out of the way pretty easily because they're both going to be the same. So D18 equals, and then if we have a look down here, we've got distance between studs, which is a calculated value. We're going to insert into relations, and we're going to do the same with D19. So D19 is the same. Select that, and we go equals distance between studs. We're going to insert that. Perfect. Okay, so if we click OK, we'll click verify. Perfect, and we'll click OK, and we'll just see what that looks like when we regenerate it. So now we've got our studs spaced out where they need to be, which is perfect. So now we've got 3 at the moment by 2, which is okay because we still need our extra studs here because we've asked it for 4 by 2. So we also need to link our pattern values, or our instance values. So what we need to do here is click back into relations, and we're going to choose our stud pattern. And now we're going to have a look here. So we've got P20 is our pattern dimension extrudes. So pattern is how many instances are going to be in that pattern. So P20 is going to be our studs long. So if we have a look here, we've got studs long. P20 is going to be studs long. So we're going to link P20 equals, right click on studs long and insert into relations. And then we'll do the other one as well while we're here, and that's P21, which is our pattern 21, which is going to be our studs wide. So it's not going to change because we've just got 2 here, but it will change when we modify it later. So we go P21 equals studs wide. Now if we insert relations, so we've got those there now, and we can go to verify. Perfect. And then what we'll do is regenerate, and there we have it. We've got our part now generating dynamically the size of the part and also the number of studs. So we could go in here now, for example, and go to our parameters tab, and we can change parameters and test that. So if we go to here and we go to studs long, and we'll change that to 2. We'll leave our studs wide to 2 and click OK and regenerate. We now have our our 2 by 2 block. Same as if we do our parameters. Same thing if we do studs long. We'll go 10 studs long. We'll go 1 stud wide and regenerate. And there's our block. Lego brick. Pretty cool, huh? It's nice and easy. Now again, I'll demonstrate to the unit height. So this one here is the standard unit height, which is the 3.2 times 3. But if we go back into our parameters and change our unit's height and change that to 1, that'll make the thinnest piece. So regenerate, and that's our thinnest piece there. Now you can see that we are missing some geometry on the bottom, which is what we're going to cover next. Okay, great. So now that we've got our part that we can visualize here, not much easier because it's nice and big, 4 by 4 studs, we need to start working on the bottom. Now we know that from our slide here that our roof height, our roof thickness is 1 millimeter, which is just the top there. It doesn't include the stud, it just includes that part there. We know that dimension's 1mm. We're going to pop that into our relations or into our parameters. So we'll just chuck in here so we've got part wall thickness, and we've also got part roof thickness, and we're going to set that to our 1mm. 1mm here. I'm going to leave it a real number because you might not want to change that, because you might want the top of the part to be stronger. For example, if you're 3D printing the parts, that's why I design these parts to 3D print. So having a thicker roof gives that little bit more strength to the part. Now, again, I normally design these things to 3D print, and with 3D printing, I haven't really included these little parts and the little cavities. I will for our demo, for our tutorial, but if you're going to 3D print the parts, play around with it. You might want to remove or leave the cavities out, these little tiny cavities inside the studs and the little flaps here, these little tiny features, for example, like the little tiny divots that come out of the wall here, the 0.6. Totally up to you if you want to model them or not. So we'll add them here, definitely for our tutorial. So we'll just do our part roof thickness as 1, click OK. So now what we need to do is create an extrusion from the bottom surface. So I'm going to go bottom surface, and I'm going to start up in this corner here. Stud 1 is this one up here. So I'm going to start on stud 1. So everything that I'm going to orientate, everything that I'm going to measure from is going to be based on stud number 1, because we know that a 1x1 block or a 1x1 smallest unit is going to be in that corner there. So we're going to try and keep everything, we're going to need to keep everything up reference to that corner. So we know that corner here, this is our 1x1 stud. So what we're going to do is pop in a reference point. So we're going to click on our bottom surface. We're going to click on extrude, and we know that this is the top corner here. We know our dimension from here, which is our wall thickness, and we also know our dimension, our roof dimension. Now what we need to do is create our center lines underneath here, because this part is going to be, or this cutout at the bottom is going to be symmetrical. It's going to be all the same around each of the edges, so we just need to make sure that it snaps symmetrically here. And we've got some dimensions created here, which is okay. We can override those dimensions now because we want to go from this side dimension to this side here, and click on middle mouse button. And we know that dimension, but we don't need to change it right now, so we just hit enter. And we want to do the same with the other side dimension, and to our other side here, and press on our middle mouse button. And now we've got our dimensions. So we can have a look here. We've got our dimensions between the cutout and the wall, side wall, and the cutout and the length wall there. And we know our extrusion depth based on our calculation, a formula. So we click OK here. Now we want to flip the direction so it cuts out the material, and it'll automatically choose remove material, but if it doesn't, just hit remove material and then click the OK button. So you can see there that it's just a little tiny divot at this point. But what we're going to do is we're going to rename that to our bottom cutout, just so we can reference to it a lot easier. We're going to go into our Relations tab. We're going to go down to the bottom of our Relations, and we're going to put in a comment, and it's going to be bottom cutout and we're going to choose our bottom cutout, and we can see now we've got our dimensions. We know that D28 and D27 is going to be our part wall thickness, and we know that D26 is going to be our part height minus our roof thickness. So let's link up our D28 to our wall thickness. And again, we just right click down here and go insert, and we will link up our D27 again to our part wall thickness. Insert that, and now our D26, because we know that the roof is going to be 1 millimeter, and we know our dimension here, our part thickness, which is our block height. We know that our overall block height minus the studs is that dimension. We need to go to equals, and we're going to go block height minus our part roof thickness. Insert, verify that, successful, and now we're going to regenerate, and we can see now that we've got a nice hollow bottom ready to put some geometry in for our studs. So now that we've got our part up to this stage, what we need to do is add the little hollows, the stud hollows. So if we have a look here, we've got the stud hollows here, and we can see that the hollows go up from inside the roof there of the part, and they go up 1.7 millimeters from the roof to the top. I'm going to do that by reference. So let's have a look here. So we always want to start from stud number 1 in the pattern, because that's where our pattern starts from. Well, that's where our part starts from. So we just we're going to extrude on this bottom surface here, and we're just going to pay attention to that stud in the corner there, the top right corner. So what we'll do, we'll hit extrude on that surface, and so we've got a reference. We add a reference to the stud itself, because then we can pattern by reference as well, because this is going to be a part of one of the pattern members. So we're going to pop the circle in here, and it doesn't really matter again what the dimensions are at this point. We just click OK, and we want to flip that into there and make sure it's removing material. I'll just drag that back a little bit, and that's our first stud hollow. So now that we've got that, we can go into our model intent in relations, and we'll click on our, actually sorry, we'll rename that first, just so we've got a better way to reference to that. So we're going to call that one stud hollow top, and we'll go back into our relations, and we'll choose our stud hollow top. So we've got our 2 dimensions here. Because we've referenced to the stud, we don't need to tell it exactly where to put it. We just need to tell the model what dimensions, what diameter we want to have for this one, and how deep it's going to go into the top stud. So we're going to put in some references here. Top stud internal hollow. So we'll call it top stud internal hollow. Now at this point we are going to, because this top hollow is going to exist only in certain conditions, which is basically this condition here where it's n by n studs. So when it's 1 by 1, there is no bottom, it's just an empty capsule or an empty segment. When it's 1 by something, this will actually be a solid stud that will come out the other way. It'll extrude rather than cut in. So this here, we're just going to say, we'll put in a condition here, if, and we'll choose studs long. So we're going to check to make sure that studs long is above 1. And, so and is ampersand, and then we'll choose studs wide above 1. So that's basically saying to the programming here, if the part has more than one stud wide and more than one stud long, we'll execute this area, and we'll end that with an end if. So that block ends with an end if. Now take note, in relations, end if is one word, one operation, one op word. Later on, when we get into program, end if is actually 2 separate words, but in this one it's one word. And we're going to choose the dimension now of the depth, which is D30, and so we've got D30. So remember, this is only going to execute in here if the part is n by n studs, where n is above 1. So we're going to have here, we're going to set this to part roof thickness plus stud height. So plus the stud height. Find that stud height. And we're going to take off 0.7. So it's going to cut through the roof. It's going to cut all the way through the stud, and then it's going to come back 0.7. So that basically means then we have that 0.7 at the top there of the roof of the stud. As you can see, that the roof of the part is 1 millimeter, and from this point, from the bottom of the roof to the top of the internal cavity is 1.7. So the difference is 0.7. And then we need to set the diameter, which is D31. So select D31. Now D31 is basically going to be stud diameter, insert, stud diameter minus 2.2. So this calculates out stud diameter at this point is 4.8, and we're taking off 2.2. So if we have a look here, the internal stud diameter of this top stud is 2.6. So it evens out there. So 4.8 minus 2.2 is 2.6. So as we scale, if we wanted to scale the stud diameter, it's going to scale it and keep it to that measurement. Okay, so that's it. That's those two. So we can verify that and click OK. Now we'll regenerate. Control G, and that's our measurement there. And that's for stud number 1. So now what we need to do is pattern that, and we're going to pattern that by reference. So it's pretty easy. We just select over here the stud hollow top, and we choose our pattern tool from here, or our pattern tool from here. It's automatically going to set it as a reference pattern, and that's because the program has detected that we've extruded into an already existing pattern member. So it's saying now, okay, I know that that's a pattern member, we're going to pattern out by reference. So it's going to take in all of those members and it's going to do that same. So we just click OK, and there's our pattern. So now we can change the model intent, we can change the parameters. So if we choose studs long, we'll make that 6. We'll make studs wide 2 and regenerate. And you can see that that follows the relations there, follow the parameters that we've set for this part. Great, so now that we've completed that, that extrusion, that cutout, we're going to suppress the pattern and we'll go on to the next condition. So that one there is the first part of this n by n, where n is above 1, but we're going to suppress this pattern now. So we just click on here and then we click on our suppress and click OK, and that gets rid of this one. And what we're going to do now is we're going to focus on the solid studs that will protrude out of here. If it's a 1 by n or n by 1 size, so basically one row of studs, either wide or long. So what we're going to do next is set the part parameter. Studs wide we'll set to 1, and we'll set the studs long to 10 and regenerate. So now if you do have a look at the standards for Lego, when it is a 1 by something part, that instead of having hollow cutouts above the studs, we have solid studs that pop out. Possibly, if they do, I'll have to have a look, but if they do have the studs, the hollow studs, we can leave that pattern in for these two conditions. But just for now, we'll leave it out, and we're going to create a new feature. So again, we're going to start from stud 1. So stud 1's over here, but we are going to select our bottom surface. So now we're on the right hand side here, and we're going to extrude onto this surface here. Now we know that this solid stud, we don't want to put it in the center, we just want to pop it here somewhere, just there. We still need our dimensions to tell it where it's going to go, because if it was longer, if it was wider than it was longer, so if it was 1 wide and 10 long, 1 long and 10 wide, would be the opposite way this way. So we still need to let CREO calculate all the references, the relations to calculate the dimensions of where the stud's going to go no matter what. So what we will do is we're going to reference from the side and the top of where the first stud is. So what we'll need to do here is pop a dimension in from here to here, and we've already got this dimension created here, and we've already got this dimension created here, the diameter of the stud, which is great. That's the only 3 dimensions that we're going to need for this one, and click OK. Now it doesn't really matter what height we set here, because we're going to set that with a relation as well, relation formula. So just click OK on that, and we're going to put in a relation, or a function in the relation to set the dimensions and the location of these studs. So we'll open up our relations, and we will select, we're going to rename that as well. Rename this to stud solid 1 by n, so that way we know what it is. And we're going to go to our relations and choose, go down the bottom and choose our stud solid, axis here, and we've got some nice dimensions there that we can use. But firstly, what we're going to do is we're also going to do some conditions here. So this part only gets evaluated and calculated if the part is in fact a 1 by n or n by 1 part. So we're going to do that by using another if statement. We're going to if, and we're going to go studs long. Studs long is equal to 1, and studs wide is above 1, and then we're going to do an OR. So our OR function is 2 pipes like that, 2 separator pipes, which is found on your keyboard. Should be above the enter key, which you use shift in that button above the enter key where you got your slash, your backslash. So we got if studs long is 1 and studs wide is above 1, or, and we'll just copy this because we're going to change that around. We're going to go if that then is above 1 and studs wide equals 1, then we're going to do this, and we'll just end if here and end that block off. So this is only going to be evaluated, so we'll just put in a comment here. This will only be evaluated if the part has 1 by something studs or something by 1 stud. And that way then it gives us the opportunity to have a 1 by 10 or a 10 by 1, and it'll still handle those as well. So then what we need to do is set our dimensions for this part. So we have our dimension for the stud height, which is D33 here. So we need to set the dimensions here for the solid stud. And we're going to make some modifications to this. So we've got D33, which is our stud height, our solid stud height, D33, and that's calculated by block height, which is the overall block height minus the roof part thickness. So we've got the roof there, and we're extruding from the bottom of the roof down to the bottom of the part. And then we set the stud diameter. We're setting the stud diameter to 3, the solid stud diameter. Now that's because the standard, even though it says here on the slide that it's closest to 2 millimeters here by the look of that, I have measured my parts here with calipers, and I'm getting close to 3. It's about 2.97. So I believe that this may not be accurate. So I've just set that to 3. So it's just stud diameter, which is 4.8 minus 1.8, which calculates out to 3. So if you ever scale the stud diameter, it's going to keep that that dimension. So we regenerate that, and we can see now we've got our stud there. We do need to set the outer parameters. We do need to set the outer dimensions, so the D36 and the D34, which is the distance between the outer edge, the right edge, and the top surface, or the side surface here, the right edge. But we'll deal with that very shortly. So the next step will be to modify the relations so we can handle those other conditions. So we've got to check to see if the studs wide is above 1, or if the studs wide is 1, and that will give us the orientation of the part. So we can either have a 1 by something, which goes this way, or we can have a something by 1, which should be the opposite way, the way that the program will generate the part. So what we need to do here, these two dimensions stay the same no matter what, because that's just the height and the diameter of the stud. But what we need to do now is we just need to do a couple of if statements. So if studs wide is above 1, and then else, and an end if. So if the studs is above 1, if studs wide is above 1, we know that it's the part is wider than it is long, and then else will be else will only be reached here if the studs wide is 1, and we already know, because it's inside this if statement, or this if block here, we already know that it's already met the conditions of studs long equals 1 or studs wide equals 1. So we don't need to double check that. We just need to confirm whether the part is wider than it is longer, or if it is longer than it is wide. And these dimensions here are going to orientate. They're going to move this stud to where it needs to be based on its orientation. So if the part is in the orientation that it is now, we would expect that D34 would actually be the middle of the part, the center of the part, and D36 is going to be the measurement, the standard measurement from the side of the part inward. Whereas the other way around, if the part was oriented bottom to top, or if it was bottom to top, it would be D36. It would be putting this stud into the center of the part, going upways. So because we're doing studs wide is above 1, so if we have a look here, if our studs wide is above 1, which it's not, this will occur, but we're actually doing this part here at the moment. So if we go here and say part is longer than it is wide, so it is, for example, 10 long by 1 wide, this is what's going to occur. So in this configuration, we would expect that dimension 34 would put the stud into the middle of the part. So to get that here, we choose the D34, and we want that to be off the top. So D34 is going to be part width divided by 2, and that'll give us the center of the part. It's going to pop the stud into the center there. Now we can also test that by setting the parameters to studs wide. We'll choose studs wide here and set it to 10, and we'll set that to 1, so it's going to be the opposite way. And we can see here that the part here, it actually hasn't moved yet, because you can see that it's a different orientation, but what we need to do is just ensure that that's still going to be in the center. So we need to, just in our relations, because it's going to be studs wide is above 1, and studs long is, well, studs long is not tested here, it's already tested above, but we'll just put a comment here. Part is wider than it is long, so it is, for example, 1 long by 10 wide. So with this scenario, You can see D34 won't actually need to be that measurement there, which is part width divided by 2, because that's to center it. We actually need to set here D36 to be that dimension. So D36 equals part width divided by 2, and that will sort out that dimension. That'll actually put that into the center, even though it's already centered at the moment. That's just because we already had that set on that value. So we'll just verify that. We can regenerate. It's really not going to do anything at the moment. Well, yes it is. Why did it do that? Let's have a look. So, yep. That's because we're going to set this now to part length divided by 2, because it's the opposite direction, the opposite orientation. Part length. Just check this one. Now that should pop us back into regenerate, and that's going to center that into that part there. Okay, great. So now that we've got this working, we need to change our D34 dimension to get the right value from the edge of the wall when studs are wider than they are long. And what we need to do is, for the Lego standard, it's actually 7.9 between there and the center. So the distance between studs is actually 8. If we have a look here, distance between studs is 8, and we need it to be 7.9. So we're just going to calculate that out. We'll just do D34 equals distance between studs minus 0.1, which will give us the 7.9. And we'll just regenerate that, and that's where our first stud's going to be. Now if we have a look here to confirm that, notice that this solid stud is actually in the center of those two top studs, which is perfect. That's exactly where it needs to be. And now what we need to do is the same with the other orientation of the part. So we're going to change that back to studs long as 10 and studs wide 1, and we'll regenerate. And we just need to set that same value in the different conditions. So in the relations, we go back down here. So here, instead of setting D34, we're going to set D36, because D36 in this orientation is the dimension now from the sidewall of the part to the center of the stud. So we're going to change that to D36 here in this condition. Just do a couple of spaces so it's a little bit more readable. And then we'll verify this here. Perfect. And then what we'll need to do is regenerate. And now, so we can see here, when the part is orientated this way, we can see that that stud is now in the correct location, right in the center of these two top studs. And now, of course, we need to pattern that. And now, with patterning this, we also need to accommodate for the two different orientations of the part. So what we need to do next is choose the solid stud 1 times n, and we want to choose pattern, and we want to do a direction, and we're going to have the direction, because the direction of the pattern obviously goes towards the surface that you select. We're going to select this surface for the pattern number 1, and just to make it a bit easier, we'll set that to 3 for now, just to see where it is. And now we know that the pattern is going to go down, so we need to make sure that we set the direction of the second pattern direction to the right side. So we're going to choose the second direction, we're going to choose this way, and that's going to give us another set of studs, which is okay at this point because we're going to use relations to sort or to calculate how many rows and how many studs wide this is going to be. Now the reason why we're doing these two directions is because we have, even though it's going to be 1 by something across, when we change the part orientation to the other way, it's going to be using this pattern instead. So it's going to be using the pattern downwards or across. So we can just change, we'll change that to 3 as well, just so we can see. And click OK. At the moment you can see that it's not exactly correct. That's okay, we're going to use some relation calculations now. So back into relations. Now we can see, and we need to make sure that we're in the right condition here. So studs wide is 1, so studs wide is not above 1, so we're working with this area down here. And we want to set our patterns for this condition. So let's choose our pattern here. Now for this condition, we only want studs to go across. So if we have a look here, we've got P40, which is the number of, well, it's the pattern 40 extrudes, so it's the number of instances of the pattern that are going to go across. So with P40, with the number of instances, if you have a look at a Lego block of that type, you notice that there's 1 less bottom stud than there is top studs, because it starts from the middle here and it goes all the way across to the middle here. So you're going to have the number of gaps in between the studs, which is studs across minus the 1. I hope that makes sense. So for P40, so for this condition, we're going to go pattern 40, and we're going to go equals. Now we know that the part is studs long, is the calculation or the element that we need to use here. So we want to go studs long minus 1, and that will give us the calculation across. So if we just verify that and we go OK and regenerate, we've got now, instead of having, we've got 10 studs on top, and now we've got 9 studs down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is perfect. But now we need to adjust the spacing between the studs, which is easy as well. We'll just go back into relations. Now we need to choose the correct element of the pattern, the correct dimension of the pattern, which is this pattern, this dimension here, D38. And D38 in this instance is going to be distance between studs. So we'll just insert that, and that there. Now if we verify and we regenerate, we've got that working perfectly that way. Okay, so what we need to do now is we need to get rid of the pattern direction, or the direction going the wrong or the opposite way. So we just need to go back into relations, and in here we need to set the pattern values, the pattern dimensions that we don't need. So P41 here, P41 is going to be set to 1 because we don't want it to go any further than 1. So P41 is going to be a hard 1, and D39 we shouldn't need to set there. So let's just test that, because what we're doing now is we're telling the program that we only want that 1 row of studs. We only want that pattern to occur in that direction at this point. So now if we do the opposite now, and we change it back to 1 by 10 and regenerate, you can see that the pattern is still there, but it's the wrong orientation now. Okay, so now that we've got it working in that other direction, we need to get the pattern to work in this direction as well. Now to do this, we need to do a couple of little calculations. Now it appears here that dimension 39 is going the wrong way, so we're going to possibly need to change the direction of the pattern. Just a moment. Let's set P41. Let's set P40 to 1. P40 is now going to be 1, and P41 is now going to be studs wide minus 1. So let's just verify that, and we'll regenerate just to test that. So now it's working, it's just going the opposite direction. And we can fix that by going into our pattern, editing our pattern, and we just want to flip, wrong one, we just want to flip that pattern there, that second direction, we flip that back that way. Okay, great. So now we just need to adjust now the other dimension. The other dimension being the distance between the studs, if the part is wider than it is long, which is going to be dimension 39. So dimension 39 here now will equal distance between studs, and we'll verify that, and we'll just regenerate, and that's going to solve that issue. So we now have the part generating these studs in the right direction, the right dimensions, and the right spacing. So if we now change that back to if we now change the parameters, we change it back to 10 long, 1 wide, and we regenerate, we get that that same pattern but on the bottom of the part instead, which is working great. So that's our solid bottom stud pattern for the 1x(n) and n by 1. So now that we've got the 1x1 parts completed, which is working really well, we need to suppress our pattern over here, switch that off now, and we're going to start working on the other condition, which is n/n, where n studs is above 1. So if the part's 1x1, 1x1, we're not going to have any studs on the bottom. But if the part is multiples of studs by multiples of studs, which we're going to set here now in parameters, this will be the next condition, or the next set of parameters that we're going to change to. So we'll set the part now to studs long 4 and studs wide 2, and we'll regenerate. Awesome. So now we have a standard Lego block, if you like. And now on the bottom of a standard Lego block, we have our round cylinders, our hollow cylinders. Let's have a look here. So we've got these holes here. And we also have the indented top patterns here as well, which we can turn back on a little bit later. We don't actually need to turn that on right now because we're going to control that later in Pro Program. So let's model these parts here. And we'll probably model these little extrudes here and the flaps, but we'll model them. We'll work on that a bit later. First of all, we'll get these hollows done, these hollow studs at the bottom. So again, we need to check where stud 1 is, which is up this corner again, as it normally is. just select that one there, just so when we flip it we can see that we're going to be working from this side of the part and the top of the part again. So what we're going to do now is we're going to extrude from the bottom of the part roof. We're going to extrude from here, just set the sketch view. We're going to add the references again of the side of the part and the top of the part there. So yeah, we can then create a cylinder. Now again, we don't want it in the middle. We don't want to attach it to this center line, because the part is going to grow and it's going to shrink, and we would like that to be able to regenerate and be in the correct location for each dimension, each set of parameters. So we've got our dimensions here for the first hole. Now we can see that there's two, because we've got this little bit of a thickness here. So our inside one is 4.8, which is the size or the diameter of a stud. So we can use the stud diameter variable for this dimension, and then we can do a subtraction here to get the thickness of this wall, and we can keep it that same thickness based on whether you scale the stud diameter or not. So we'll just create our other circle, and so now we can click OK on that, and we can click OK on that, and there's our geometry, there's our feature, sorry. And we're going to work on the relations for this condition here. So if we have a look here, we've got our if statement for our if studs long is above 1 and studs wide is above 1. This is where the code is going to reach, or this is where the conditions will be read from, because our studs is going to be our studs long is going to be above 1, and our studs wide is going to be above 1. So in here, actually, again, I need to rename this to bottom hollow stud feature, and back into relations, and find our conditions here. So if studs long is above 1 and studs wide is above 1, and we'll choose our bottom hollow stud, and we will select our dimensions, and we'll create our relations for those dimensions. So let's have a look here. We first of all need to set our first dimension, which is the internal dimension of our hollow stud, which appears to be this one here, D43. So D43 is just going to equal stud diameter, certain to relations, and our D46 is going to be stud diameter plus, and the difference of this one is 1.7. So 1.7, and we get that 1.7 from here. So 6.5 minus 4.8, 1.7. So 4.8 plus 1.7 is the 6.5. So we can test that in a second. But we also need to set the other dimension, which is D42. And D42 again is going to be the block height minus the part roof thickness, and we'll verify that.
we have an error. What is that error? Extra symbols ignored. Oh, that's because we've got two equal signs. Block height minus part roof thickness. And we'll just regenerate. And we can see now that the stud is the correct dimensions. It's just not in the right location yet, which isn't a problem. We can fix that. Because we know that that's going to be the first stud, the first hollow stud, we are going to set the dimensions to locate that first stud. And then from there we'll pattern out. So we know that to get into the center of these first two studs, we need to go in 7.9 millimeters from each of the sides, which is our spacing between studs minus 0.1. So we're going to do the same thing here. We're going to go D45. D45 equals distance between studs minus 0.1, and we're going to do the same here for D44. We just need to re-dimension that because that's coming from the wrong direction, so we just need to edit this here. We've got our dimension, but it's coming from the center line here. We want it to come from the top there, so we're just going to replace that one. Go back into our relations now. We've got the right dimension that we can set, D48. So D48 equals distance between studs minus 0.1, and that's going to put our first hollow stud in the correct location, so it's going to be centered between those four studs at the top there, which is great. So it doesn't matter now what orientation this part is in, that first hollow stud is always going to be in that one position, so we can test that by changing our studs. We'll change our orientation by going 2x4 and regenerate, and we can see that the first stud is always going to be in that same position no matter which orientation that it's in. That's because it's centered to that first set of studs. So from here now what we need to do is set our pattern up for this stud. So we want to click on our bottom hollow stud and we want a pattern. And again we want a direction pattern. And our first direction again is going to be the opposite side of where it's coming from. So I'm going to set that to, we'll just leave that as 2 because it's going to be 3 eventually. And we'll just set our second direction to our bottom. Now if it is, again, if it's in the wrong direction, we can flip it by clicking this here once we know that it's in the wrong direction. So let's click OK on that. And we've got our 4 bottom hollow studs at the moment. And at the moment, at the moment it's 4. But you can see that we just need 3 evenly spaced out because that's the Lego standard, which means that the studs across is going to be however many studs minus the 1. So next step, we need to pattern. We need to modify our pattern parameters or pattern dimensions here in this condition. Click on this. Now let's have a look here. We'll pick apart what we need here. So our P51 which is studs wide, studs long. No, studs wide. So P51 is studs wide. We choose our P51, and this is going to be studs wide -1, because the studs wide at the moment is 4, and we need 3 to go across that way. So P51 equals studs wide -1, and we'll just test that, because that should give us 3 across now, which it does. Go back into our relations, and what we need to do now is set our P52, and P52 is going to be equal to studs high -1. So if we have a look at that now, studs wide -1, studs high -1. Studs high is not studs high, studs long and studs wide. Studs long. So studs long at the moment is 2. So 2 -1 is 1. So we should only get that 1 pattern there. So let's just regenerate. It's perfect there. Now we just need to set our distance between studs for both directions. And we're going to set our distance. So our distance now, so because we've run that, one of our patterns has disappeared, so we can't actually see I believe we can't see the dimension that we need. So what we can do here is set our relations. We can set our studs long. We'll set that to 3 as well, and regenerate. And now we've got that back again. So we can go back into here and we can set, we've got our D49, yes, D49 is our distance between studs, so equals distance between studs, and I believe our D50 is also going to be our distance between studs, but again I think the direction is in the wrong, I think the pattern's going in the wrong direction, but we can fix that. So let's regenerate that. Regenerate, yes, so our pattern's going the wrong direction, so again we can just click on the pattern here and click on the edit, and we just flip that over, and there's our part. So now we can change that back to studs long. We'll change that to 4, studs wide 2, and we'll regenerate, and we can see we've got that there. So we can also now test that by setting it to studs long. We'll change it to 12. We'll change studs wide to 4 and regenerate. And you can see there that we've got our bottom studs working right there. Okay, great. So now that we've got everything working, and we've got all our features suppressed, all our patterns suppressed, we need to set our patterns to show and hide based on certain conditions. Now our stud hollow top pattern, it's going to be displayed no matter what, so we can show that, and we can leave that on there because that is going to be shown whether it's a 1x1 stud pattern, or 1 by something, or something by something. That's always going to be shown. It's always going to be a feature that's shown. So we'll leave that on there. So what we've got now is we've got bottom hollow studs, and we've got solid studs 1 times n. So let's focus on bottom hollow stud pattern, because that is going to be shown if the part is n by n, where n is above 1. We're going to display our hollow studs. So we've got this pattern here. We need to find out what our feature ID is. So our feature ID is defined in the Pro program, and we need to be able to reference to that. So what we need to do is right click on the pattern and click on information and click on feature information, and we can see here that the internal feature ID for bottom hollow stud is 2399. So make a note of the feature ID, which is probably going to be different on your screen, which is okay. Just make note of the internal feature ID. And what we need to do now is we need to find the suppressed pattern or the suppressed information with that ID. So let's enable that. Let's resume that pattern, because that's what it's going to look like. And what we'll do is we'll go into Model Intent Overflow, and we'll click on Pro Program, and we'll click on the Edit Design, and it opens up the Notepad document that shows all the different features and the different commands that CREO Parametric uses to put this actual part together. So what we need to do in this file is we need to search for that feature ID, and we can just search by typing it in here, find, and we find it here. So this is feature, this is the bottom hollow stud feature pattern feature. We need to put in an if statement here to detect, to check to see if the part dimensions are n above, or number of studs wide is above 1, and number of studs long is above 1, because that's the only time we want those bottom hollow studs to be shown. So let's start by saying if, and then we've got our studs wide is above 1 and studs long is above 1, then it's going to execute this feature and this set of features. So what we need to do now is we need to go down past all of that. So we've got the pattern feature. Now if we were just to stop here and go end if and only not add the pattern, it's going to come up with an error, and I'll show you why. So if we close that, we've got this error here, and that's because we not only need to suppress the pattern, but we also need to suppress the members of the pattern as well. So if we have a look here now, it actually comes up with the error here. You cannot separately delete or suppress a pattern or its members. So these are the list of the members that we also need to make sure are suppressed. So if we pay attention to these numbers, we've got 2359, 2401 and 2731. Now they'll all be in order after these errors. So what we'll do is we'll go down, we'll take this end if out, because we now need to put that end if after the last feature. So we're looking now for 2731. So if we keep going down, we've got 2359, and we've got 2401, and we've got 2371, and that should be the end. Yes. So here, just here, we need to add in our end if here. So end if and save. And now if we close it and go yes, and then hit done and return, regenerate, it's not going to change anything because that's where it's meant to be. So if we want to test that now, we will go into our parameters and let's change our studs wide to 1 and we'll regenerate, and you can see now that it's hidden the bottom hollow stud. So you can see here now we've got this little suppress feature and it's actually suppressed it. Now as you can see too, because it's a 1x1, we actually need to make it unsuppressed. We need to resume this feature here, which is our pattern 3. So again, we do the same, we right click and go information, feature information. We've got our internal feature ID 1468. So we'll make note of 1468. And we're going to do exactly the same thing. We're going to go back into Model Intent Overflow and Program. We're going to click on Edit Design. And we're going to search for 1468. So 1468, we've got Add Suppress feature. We can take out the suppressed keyword, or we can go back into here and resume that solid stud. We'll do that. So close this down, hit yes, and hit done and return. And we'll just click over here and we'll click on resume. So then that puts in our solid stud. So that's what it's going to actually look like when it's going to be a 1 by n or an n by 1. So let's go back into our Model Intent Overflow and then click on Program. Click on Edit Design again. And now what we need to do again is find our feature ID 1468. We notice now it doesn't say Add Suppressed feature anymore, it just says Add Feature. So above that line we're going to do an if statement as well. We're going to go if studs wide is above 1 and studs long equals 1, or studs wide equals 1 and studs long is above 1. So that is now the same, it's the same if statement, it's the same set of conditions that we used earlier in the relations, and it's saying if studs wide is above 1 but studs long is 1, or if studs wide is 1 and studs long is above 1, so that means the part is going to be 1 by something or something by 1, then we'll complete this pattern. We will show this pattern. Now, again, by all means, if you want to get that same error to list all the members, just type an end if here with a space and save, close it, and then you get the program error. Click Edit again, and then have a look here and it'll tell you these are the members here that still need to be hidden. So what we'll do is we'll remove the end if there, and we need to go down until we get to 2168. So 2168, let's have a look, 2167, 2168, so we go all the way down, so there's the add feature starting, and we go down to where it says end add, and we're going to put our end if in here, and save it, close, and go yes, so, and then click done. So now what we can do is we can test that function. We change our parameters, and we can change it to studs long 1, studs wide 12, and regenerate, and you'll see that it's created those studs, and it's got the bottom hollow stud suppressed, which is great. But then we can go back now and change our parameters, and we can change that to 2 long and regenerate, and we can see now that the solid stud's hidden and the hollow stud is shown. So that's perfect. So the next thing we need to do is test our 1 by 1 and ensure that our 1 by 1 is created correctly, which it is, and that's our 1 by 1 stud too. Okay, great. So now that we're up to this stage, we don't want the user to have to keep changing parameters by clicking on model intent and then clicking on parameters and changing. What we can do is set the program to ask those parameters when you regenerate the file. And to do that, there's a little section in the program called input. So if we click on model intent overflow and click program and click edit design, up the top here you've got this input and end input. So the format for inputs is pretty straightforward. I've got it copied and pasted here. So input and then input. So the format is variable name or parameter name, data type, and then the next line is the prompt to ask the user. So we want to ask the user how many studs long for the part, how many studs wide for the part, how many units high for the part. So remember, 1 unit is 3.2 millimeters and 3 units is 1 standard block height, and whether or not to have studs on top, and that's a yes or no. So I'm just going to copy that and paste it into my file. You can ask whatever you like really here, and it'll set those parameters. And because it's setting those parameters here, it's going to reflect, it's going to continue with those values rather than trying to use them from our parameters window. So now that that's pasted, we can save and close, and we go yes. And we're just going to go current values for the moment and hit done and return. So now if we regenerate, Control G, or hit the regenerate button up here, a little menu pops up and it says get input, and you can use the current values that are already there, so you don't have to keep changing the values. You can use current values, and that'll just show what you've already got there. I'm going to regenerate though, and I'm going to enter some values. So when you click on enter, it's going to ask you what values you'd like to specify, whether you'd like to specify studs long, studs wide, units high, or studs on top. So I'm going to specify each of these because I want to set it back to 3 units high. I want to put studs back on top, and I want to set it to 6 by 6 studs. So now that I've selected that, I hit done cell, and then it's going to ask me for the prompts here. So how many studs long? We're going to say 6. How many studs wide? We're going to say 6. How many units high? I want it to be 3. And do I want studs on top? Yes, I do. And there we are. And what we'll do is we'll regenerate again, and we'll enter some more values. I'm going to change the studs long. I'm going to change the studs wide. I'm going to change studs on top. I'm going to go done. So studs long, I'm going to set that to 15. Studs wide, I'm going to set that to 2. And I want studs on top, yes. And then we've got 15 by 2. So again, we could export that part as an STL file, stick it into a slicer, and we could 3D print that. We can do whatever we like with it. So hopefully you found something in this tutorial interesting or helpful. Again, my name's Anthony Musgrove. I'm a Senior Engineer with LabWorks Australia. If you have any comments or suggestions for future videos or ideas or anything you need to discuss or want to talk about, feel free to leave them in the comments below, and I'll do my best to get back to you. And thank you again for stopping by. Don't forget to like and subscribe. It'll help me create more content in the future.